The given diagram shows the flowchart for a recursive function an. Assume that all statements except for the recursive calls have O1 time complexity. If the worst case time complexity of this function is big of n power alpha, then the least possible value of alpha is dash. So this is a question regarding solving recurrence relations. Now in this question they have given us that we have a particular recursive function an, and this is the flowchart for an. Now let's try to calculate the time complexity of an. So in this flowchart, if you see, there are 4 particular paths that we can take. The paths are, we can take this path, or we can take this path, or we can take this path or this path. Now if you are taking this path, it will be calling a of n by 2 2 times, and in this path it's calling a of n by 2 3 times. In this path it's calling a of n by 2 4 times, and in this path it's calling a of n by 2 5 times. Now to calculate the time complexity of this function, we need to take the worst path that it can take, which will give us the maximum time complexity, that is this path. Now this path has how many a of n by 2's? It is 1 2 3 4 5. So this is the worst case time complexity of the function when it is always taking this path. So the recurrence relation for this function a of n, I can write it like this: a of n will be equal to 5 times a of n by 2 plus f of n, where f of n is the time complexity of the rest of the parts. Apart from these a of n by 2 statements, what other statements are there? It's the time complexity of that. Now in the question it's given that except for the recursive calls, it has O1 time complexity. So f of n will be a function having O1 time complexity. So if you take a look here, a of n equal to 5 times a of n by 2 plus f of n. Now this type of recurrence relation we can easily solve using the master theorem. Now if you don't know about master theorem for solving recurrence relation, please learn about that first. It will be helpful for solving many these kind of questions. So in master theorem, we can take this as a and this will be b. In master theorem we are writing recurrence relations of the form t of n equal to a into t of n by b plus f of n. Now a is 5 and b is 2 here. So the complexity of this function will be big O of n raised to log a to the base b. That is the case 1 of master theorem. We can write it like this: if the function f of n has a time complexity less than O of n raised to log a to the base b minus epsilon. Please learn about master theorem in order to find out how I got that. So for this one, using case 1, I can write the complexity as big O of n raised to log a to the base b. That's equal to big O of n raised to log 5 to the base 2, that is n power 2.32. Now that is the value of alpha. 2.32 is the answer.